Okay, so let's talk about transformations of logarithmic functions, just like we did in exponential functions. So let's begin with simple transformation y equals logarithm of x plus 3. So here you don't have a base, which means this is a common logarithm. That means with base 10. So if you consider this example, so this is a horizontal shift with parent function y equals log x. So here plus 3 inside the parentheses causes the shift of the graph left by 3 units. Remember, inside changes like plus or minus next to x move the graph left or right, but in the opposite direction what you might expect. So let's try to sketch this. I have already sketched the two functions. So this is the parent function y equals log x. So here the vertical asymptote is the uh, y axis, and it passes through this point, and this is defined only for x greater than 0. So here, in order to get y equals log x plus 3, you have to do a horizontal shift by 3 units, which means you have to move this function left by 3 units. So here, if you transform this parent function, you will get a vertical asymptote x equals negative 3, and the graph is shifted left by 3 units, and now the domain is all the values greater than negative 3. So the shape of the graph stays same, but it just moved to the left. That is first example. Moving on to the second example. So now you have y equals 4 plus log x negative 2. Again, you don't have a base, which means you are looking at common logarithms. Okay, so if you consider this expression has two transformations applied to the parent function y equals log x. So let's talk about these two transformations. So first transformation I see is in log x negative 2. So this is a horizontal transformation. So this is a horizontal shift. The graph shift right by 2 units. And if you consider 4 plus log x negative 2, so now here we have a 4 outside of the log function, which means this is a vertical shift. This is going to be a vertical shift. And the whole graph moves up by 4 units. It's an upward shift. So in summary, this function over here, we can see a shift for right with 2 units, and also it's going to move upward by 4 units. So here I have the sketch for this function. So this is the parent function, and then you have to move this to the right by 2 units, and again you have to move that same function to the up by 4 units. So if you move that, this will be your resulting function. So here the vertical asymptote is x equals 2, and the domain is all the values greater than 2. So these types of transformations you can try to sketch using calculator and try to understand this as well. Next example. So here you are looking at y equals 1/3 log x. So again, this is based on the parent function log x, y equals log x. So this is what's happening here. So actually here you have 1/3, which means this is going to be a vertical compression. Vertical compression. So here you have factor 1/3 in front of the logarithmic function. This causes the vertical compression. So actually, because of this 1/3, which is less than 1, so it flattens the graph. So for every y value is now 1/3 as tall as the original graph. So the graph still passes through 1, 0, but it rises more slowly. So here I have the graph of 1/3 log x, which is this. So this is more flattened than the original function. So here's also the vertical asymptote is same as the parent function, which is x equals 0, and the domain is all positive values. But the graph is still increases, but it's not steep as the original function. So this is how you do transformations of graph using logarithmic functions.